All right, folks, gonna hop right into the math for this week. The first thing isn't difficult at all. It's actually something that I taught a little bit last week, and just has one or two more tiny rules you need to know. And what that thing is, remember last week when we were multiplying like 59 times 10 to the second power, right? And we just rewrote that 59 and added in the two zeros based on our exponent. So that's one of the main things you have to be able to do this week. It's just more practice on that. And then learning a few rules when it comes to dealing with exponents. So when you have, let's say we have 85 times 10 to the zero power. Whenever you see something to the zero power times 10 to the zero power, it's just going to be whatever this number here is on the left hand side. So this 10 to the zero power is the same as 1. So 85 times 1 gives us 85. So whenever you see this, 10, anything to the zero power, it's 1, right? So 10 to the zero power is the same as 85 times 1, which is 85. So whenever you see a number multiplied by 10 to the zero power, just know, hey, that number is now 1, and I just have to rewrite what's here on the left-hand side. So once we get into get a little bit deeper on the process and in this context, some things might, what is it? There's some different things that might come up and you might encounter. But for now, if you remember this, you are good to go. Another thing that they're going to be asking you to do this time around is knowing like if multiple things will have the same answer. For example, if we have what is it? Sorry, not the same example, but if something is true. So if I write 48 times 10 squared, and I go, hey, is this equal to 400 or 4,800? And you look at that and you go, yeah, it is. So can you read a equation and know if it's actually correct? So 37 times 10 to the third, if I put 37, that's not equal. So you have to be able to look at a list of equations and see, hey, is this true? Is this not true? Is this true? Is this not true? Okay. So this is the first portion, and it's super easy. Shouldn't really give you any stress at all. Now, the second part of this week's math that might give you a little bit of a hassle, and what is it? Normally, I would separate these into two separate videos, but because they kind of touch on the same point, I'm just going to put them together because they kind of work off each other and feed off each other. And so you're still going to have those two topics, but you only have one day really where you're introduced to both these topics and the rest of the week to practice them. Starting next week is when we're going to have those four complete topics, two on Monday, two on Tuesday. So be ready for that. Be ready for that increase in complexity and in time. So make sure you're managing your time properly. Now, for this next portion, what we're going to be learning about is decimals and power 10. So, for example, if I have a number, let's go with 835 thousandths. Remember, when you're dealing with numbers after the decimal, you want to put that TH there to let you know that it's a piece of getting to 1. So here would be we did this last week. I made a video about it. So this is just a quick recap. This is not the tens place. So the ones place is here where there's a big goose egg, 0 here. This is the tenth place, right? And so what you're going to notice is it follows the same pattern as numbers do on the left-hand side of our place value chart. So this is 1, right? Now 10, hundred, thousands. This is 1, so we have tenths, hundredths, thousands. So for the math of this, it's actually super simple. So if we have 835 thousandths and we multiply that by 10 to the second power, what you're going to do here on the previous ones, when it was a whole number, we just added zeros for what is here, for the exponent. But since we have this decimal, we're not going to add zeros. We're going to shift our decimal to the right. You guessed it, 2 places, because that's what's there. So we start here and we shift that decimal once, we shift that decimal twice, and then we just rewrite our number. And there's your answer. There's no math, really. It's just sliding over that decimal the amount of times that you see here. Okay? I'll give you another example here. So if I have 7 and 69 hundredths, and I multiply that by 10 to the fourth power, I'm going to move this over 4 times. Let me make this bigger so we can see exactly what I'm doing here. I'm going to slide my decimal to the right 4 times. 1, 2, oh, I'm going to go 3, 4. Now you see we have these empty cradles here, these empty spaces. Whenever you see an empty space, what you need to do is you need to add a 0 whenever you have an empty cradle. The way we talk about it in my class is there's an empty cradle, put the baby inside the cradle. Babies like to be held and cradled, so put that 0 there and then rewrite the number. The decimal now is at the end of our hoops here. So this should be 76,900. Okay, so it's not too difficult. Remember, when we go into small group, we're going to talk about this and do some practice. Now, the only wrinkle and thing that's a little bit unintuitive is sometimes you're going to get something like this. You're going to get a 9,000 times 0.01, right? So when you see something like this, what's actually happening here is you're going to be dividing because you have a fraction, right? So multiplying by a decimal is kind of the same thing as dividing. And our decimal that we have here is going to move to the left instead of the right. Now, if you look here at this 9,000, you might say to yourself, Mr. Hill, you're talking about decimals, but I don't see a decimal. Now, remember, every single whole number has a decimal at the end. You don't always write it, but it is there. 1 second, just want to double check, make sure I'm not forgetting anything that you are going to need for today. Okay, so even though the decimal, I didn't write it there, it's always there. At the end of every whole number is a decimal. There is no if, ands, or buts about that. If you have a whole number, at the end there's a decimal, whether we write it or not. And so we're going to slide that decimal to the left. Now, how do we determine how many times do we move the decimals to the left? For, when we're moving to the right, we're multiplying by 10 to some power. We look at the number on the exponent, right? So if the exponent's 3, we move over 3 times. And if there's anything open, we add the 0. Here, we're going to do the opposite. We're going to move to the left, but we're not going to check the exponents. We're going to check the amount of zeros we have, right? And there's an exponential reasoning for that, but I don't want to confuse you guys too much at this point. So just know, hey, I have 2 zeros here. So that means I'm going to move over 2 times. 1, 2. Now, instead of 99,000, I just have 90. Okay, now I have these 0.00. I don't need those anymore. When you have zeros after your decimal, you have your decimal, then zeros after that, you can just go ahead and let those go. So our answer is going to be 90. So let me show you again. It is not very difficult. It might seem a little strange at first. Grab another problem from the book here. So we have 0 and 418 thousandths, and we're multiplying that by 0.1. Now again, we only have the 1 0 here. So we're going to slide over to the left 1 time. So we're going to go here. We're going to slide over to the left 1 time. Our decimal goes there, and then we write 0.418. So it's about shifting our decimals, right? Left or right when we're dealing with decimals and exponents. If you see something that is a normal base and exponent, you're going to move to the right. If you see decimals, right, you're going to move to the left based on how many zeros you see. Now, why are we doing that? I just want to quickly explain. This is something at the end here. If you got this and you want to go ahead and get started, go ahead, start getting to work. You do not have to continue watching, but I just kind of want to quickly explain what's happening, right? So basically, what you're seeing when you see that decimal place, you're seeing 10. So 10 to the negative 2 is the same thing as 0.01, right? So that's what you're seeing. And this, in order for me to describe this, I got to go into a whole lot of math, and we got to go over negative numbers and what that means, and flipping and multiplying, dividing, all this other stuff that comes up from here. So I don't want you to be too confused, and that's why we use this here, okay? So that was just a quick quick and kind of rushed example of why that's happening, but you don't need to know this part yet. We're going to learn that in 6th grade, 7th grade, a little bit further. Just know here, you see, hey, I have 2 zeros. I'm going to move over to the left 2 times, and that should get you through the majority of what you need to work on. So good luck. And if you have any questions, remember, hop in during open Zoom time today or throughout the rest of the week to get that help and assistance you need.